Namaste, myself JV'N Goyal from the Faculty of Physiotherapy and Diagnostic in the Department of Diagnostic and Community Health in the discipline BScRT. So, today we are going to discuss on the session about radioactivity. What is radioactivity and about the radioactive decays. There are three types of decays. First decay is the alpha decay, second is the beta decay, third is the isomeric transition or gamma decay. So, this topic is particularly important in the general radiation physics first for BScRT first semester. So, let me start. General radiation is first. Topic is the radioactivity. Okay. Radioactivity is a nuclear phenomenon that was discovered by the scientist Henry Becquerel in 1896 when he was investigating Becquerel left some uranium salt on the photographic plate lying in darkness. Then after development of the photographic plate, he noticed that the photographic plate emits some invisible rays. So after that he repeated the same experiment with the other uranium salts, and after that he concluded that the uranium and its salts emit radiation like alpha, beta, gamma radiation. Those rays can pass through wood, paper, and glass, any object. Glass, like thick object or thin object. And later the Becquerel named for these rays as electromagnetic radiation. Later he concluded or gave the name of gamma rays. Gamma rays, these are the rays that is emitted in any radioactive decay process. Okay, so the radioactivity is a process by which a nuclei undergo a disintegration and emits some rays like alpha, beta, and gamma rays. And if a nuclei is unstable and shows radioactivity, then it is known as radioisotope. The end product of a decay process or disintegration is called daughter nuclei, and the first that initiate the process is the parental nuclei. Okay. After disintegration, after decay, an atom changes its the change occur in the atom is atomic number and chemical identity. These are the two specification properties that is changed in the process. Okay, the process of radioactivity is divided into two types: natural and artificial activity. Natural radioactivity is a process by which a nuclei decay spontaneously, and natural activity is a property. Natural activity is property or shown in the atom or nuclei that having higher atomic number or more than 82. The example of the natural activity is a potassium and the radium 226. Okay, these are two examples of the natural activity. Next, we will discuss about the artificial activity. It is also called induced activity and discovered by the Curie and Juliet in 1934. So artificial activity, it is a process by which a nuclei undergo disintegration and unstable nuclei is formed, that is in metastable state, and the nuclei that is unstable is called isomer. So nuclei that is formed is isomer. After that, it is converted or it goes in the spontaneous emission. Okay, so this process is called artificial radioactivity. The examples of the artificial radioactivity is phosphorus and uranium 230. So these are the process of the activities. Next we will discuss about the activity. Activity is referred to the disintegration rate of the radioisotope or radioactive element. It is the unit of the radioactivity is the unit of the radioactivity is the Curie. One Curie is the unit. One Curie is defined as the number of disintegration per second in 1 gram of the material or radioactive medium. So the value of the 1 Curie is the 3.7 10^10 dps. But in general, the unit of activity that is used is millicurie and microcurie. The value of the millicurie, 1 millicurie is equal to 3.7 into 10^7 dps, disintegration per second. Microcurie is equal to 3.7 dps. The SI unit of the activity is a becquerel, and 1 becquerel is equal to 1 dps. So the 1 millicurie is equal to 337 mega becquerel. Okay. Now we discuss about alpha decay, alpha, beta and gamma decay. Alpha decay. Alpha decay is mostly performed in the nuclei or that's atom which atomic number is higher than the 82. So mostly occur in the higher atomic number nuclei. In the atomic number, there is a change in the atomic number. Atomic number is reduced by 2 and the mass number is reduced by 4. For an example, alpha decay is conversion of radium to radon. So 88 radium to 26 is converted 86 radon to 22. Then alpha particle is emitted with an energy. This indication is 4.87. So this is the disintegration energy, and this is the alpha particle is emitted. The conversion of radium to radon is the example of the alpha decay. Okay, so this is the process of alpha decay. Alpha particle having the charge, alpha particle having the atomic number 2 means it is represented by 2He4, and the charge is present in the helium He plus 2. So the next topic is beta decay. In the beta decay or the process, an electron or positron is emitted in this process. In the beta decay, there is an increase of an atomic number by 1, or and beta decay, beta plus decay. In beta plus decay, there is a decrease in the atomic number by 1. So the example of beta minus decay is the cobalt. Okay, in the cobalt, 27 cobalt 60 is converted 28 nickel 60. There is a change in the atomic number by 1. So that is an example of beta minus decay. There is when an atom or nuclei increases the atomic number by 1, then it is beta minus decay. The example is conversion of neutron into proton. That is the example of beta minus decay. Or the example of beta plus decay is proton is converted into the neutron. So in the topic we had discussed about the beta decay. Next topic is the gamma decay. This process is occur when an unstable or higher energy level nuclei return to its ground state. Then gamma photon is emitted. Okay. The gamma photon is emitted by the process of isomeric transition. The example of the gamma photon gamma decay is the cobalt conversion and cesium conversion. In the cobalt, when it is converted from the cobalt to nickel, there is two processes. First is beta minus decay. Second is 2 gamma photons is emitted. After that, the 28 nickel 60 is formed that is stable in nature. So that is the process of decay. So thank you. This session is over. If you have any queries, then put it into the comment box. I'll resolve it later. Thank you.